Hi, students. I want to share with you about how to do the physics interactives that I sent you guys on Forces. I sent you a direct link to that particular one, but I just want to show you and share with you how to get there from our regular, the main page of the physics classroom. So this is the main page, as you guys remember, and I'm going to click on Physics Interactives, how we get there normally, and then I'm going to scroll down so that we can get to the ones on the laws of motion. So I'm going to click here, and this is the one that you guys will be doing, the one on force. I'm going to slide down a little bit so you can see the other ones on balance and unbalanced forces, free body diagrams, rockets ladder, which one doesn't belong, skydiving. So those are some other ones that are there, but we're going to do the one on force. So let me click that one, and I'm going to launch the interactive. So the link that you all have will take you directly to this page. So I'm going to click on this one and go ahead and launch this one. You have a handout that goes along with this one. I'll share with you how to do that, how to fill out that as I'm showing you how to use the interactive. Okay, so let me go ahead and expand that. And I'm going to shift my screen a little bit so you can see everything. Hopefully you can see everything there. Okay, so let me show you how this works. Okay, so we have a mass on a table, and you can actually, it shows you that it has mass. You can vary the applied force and also the friction. And also you get this, look at that, velocity versus time graph. So we will talk about that in a minute. Okay, so this is what it looks like. So I'm going to start this interactive. And so it takes you now to a live screen. So here is where you can vary the mass up or down. The maximum is 5 kilograms. You can also vary the applied force that you apply. See, there's your applied force, there's your hand, and then you will press the push it button, and then it'll actually apply that force. And this is something different for us, where we can actually vary the amount of friction. So we can increase the friction, the roughness of the surface. But for the first one, or the first assignment that you're going to do on this one, you're just going to have no friction there. It's going to be able to move freely. Okay, so this is one of those situations where there's no friction force. Okay, so let's just show you what happens. So if you let's say have the mass at 1 kilogram, and you have an applied force, let's say of 40, and then you push it there, okay, and it just moves along, okay? So part of the assignment will ask you to give me some velocity time information. And so here's a clue to what you need to do. It says click on a point to view the coordinates. So I'm going to click on that point, and if I click on another point, that other information will go away. But let's look at what this information has. It has the time and the actual velocity. And here's another coordinate that has the time and velocity. So what information can I actually get from this velocity time graph that was produced from the motion of you pushing on that object? Well, hopefully you said acceleration, because the slope of the velocity time graph, like we've learned before, gives you the acceleration. So those coordinates is something that you're going to need to record on your sheet, okay? So the first part of the assignment has to do with varying mass or applied force. It gives you some scenarios or trials that it's going to have you to do, okay? The next part that you will have to do will be to actually change the friction, okay? So this is the part where you can actually, let me reset. This is the part where you set your friction at a certain amount and essentially do the same scenarios that you did at first, okay? You set your mass, you vary your mass, or, well, the instructions will say, I don't want to give too much away, but the instructions will tell you what to adjust in order to see what the effect of friction is on the motion. What do you think will happen? how can you find the information to tell you the effect of friction? Okay, now this isn't the friction force. This is actually what's called the coefficient of friction, which is the roughness of the surface. So we'll have numbers starting from like 0, surface friction, coefficient of friction of 0, which is like, on ice, something that gives you very little friction, versus something very, very high, let's say up to like zero point 0.9 in terms of the coefficient of friction, which is again the measure of the roughness. It's not the actual frictional force, but it's like, the relative roughness of things. And so like 0.9 would be like a gravel road or sandpaper, something very, 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 very rough. Okay, so that gives you an idea of what that means. For the first part, you're going to have that friction set to 0, and you're going to do some analysis, okay? All right, so let me show you the actual sheet that you guys will be using, okay? And it looks like this. So this is the first one. This one, as I mentioned, is for a frictionless situation. And if you read the instructions there, here it has set the friction value to 0 and run the following trials. And this is the part I was talking about here. You would set your net force or, vary that. Here's what your applied force, your mass. And remember we talked about the net force. So if I don't have any friction, what do you think the net force will be if you just only have the applied force? And here's that velocity time information where you put those 2 coordinates, and then you can use that to find the slope, which is the acceleration. So you would complete all of that there. And going down to the second sheet. Now this is where you actually have to analyze what you found. So it's asking, what effect does doubling the net force have upon the acceleration? So you will go back up to one of your scenarios. And let's say, when was the net force actually double? Okay, again, keeping the mass the same, what happened or how did the acceleration change when you had doubled the net force, which will be, in this case, just to let you know, it will be doubling the applied force, since there's no other force to oppose your applied force. So that is like the only force that's there in the x direction. Okay, so that's how you would kind of look at those questions, pick out the scenarios, and you can tell me down here which scenarios or trials that you looked at to help you answer that question. Here's another one. What effect does a tripling of the net force have on the acceleration? Does the acceleration triple? Does it not change? Like, what happens? So give that a go. So you have some different questions, different scenarios where you're asked to answer the questions about. Okay, and here is just something here, the last page, where we're asking really you to think about what variables affect the acceleration and how do they affect the acceleration. So give 2 or 3 good sentences at least that will support your claim. Okay, so that takes care of when you do not have any friction. Okay, the next scenario or next situation will be, okay, what if we added friction into the whole game here? What changes, if anything changes? Okay, so here's some background information, and this is what it's asking you to do. Conduct a control study in which you determine the effect of varying the applied force upon the acceleration in the presence of friction. Think hard about what variables you want to change and what quantities you want to keep constant. Run the trials, okay, and calculate the acceleration like we did before, where you click on your 2 data points. Now, just like in the first one, let me make sure. Okay, so in this one, you're asked to plot the data, and it says perform a linear regression. Do not worry about that part. We haven't talked about that. But I do want you to plot the data and think about what data you need to plot and actually to answer the question. Because we want to generate an acceleration equation. We'll talk about that when I get back. But the main thing I want you to do is to get your different trials, be really, really clear about what variables you need to change and which ones you need to stay constant rather. And then the plot. And I'm going to put a piece of graph paper here. Here's the second page. This is just repeating kind of what you need to do there. But I'm going to have some graph paper, and you're going to complete your graph. Do not worry about the linear regression. Okay, and here is another challenge. This is going to be for extra credit. Yes, I did say extra credit. And this is for what is the effect of varying that coefficient of friction. How does varying that coefficient of friction affect the acceleration? Again, run some trials, really be clear about what variables you need to change and which ones you need to keep constant, and be able to plot that data and see what happens. Again, do not worry about doing that linear regression, okay? But the plot itself should give some insight. And this goes with that question, that extra credit question about the effect of the coefficient of friction. What happens when you change that? So it says challenge two, that just goes together. Okay, that is not something, extra. So it'll say the same thing for challenge one, they go together. Okay. All right, so wanted to go over how you would complete that Force Interactive on Physics Classroom. All right, have a great day.